Hey guys, so that's me again talking about waves. In this video I'm going to tell you about terms like amplitude, wavelength, frequency and wave speeds. So ways that you can describe a wave. So a wave can be described by using these keywords that I just told you, and this is how it looks like. So I have here two transverse waves actually showing, and the wavelength, as the name says, is the length of the wave. So you go from one point to the wave and you'll measure the distance from that point into the complete exact point of the wave. So it could be two peaks, for example. A peak is the highest point on the wave, two troughs, the lowest point of the wave, two middles from going down, for example, so from here to here, or two middles from going up from here to here, okay? So wavelength is the length of the wave. A complete wave then gives you the wavelength. Peak, as I told you, the highest point of the wave. Trough, the lowest point of the wave. Amplitude is the height of the wave. So that's going to be the distance from the wave's normal position, so if there were no vibrations, up to the peak or the trough, because the wave moves the same distance up and down, okay? So the amplitude is going to be the maximum displacement from the normal position of the wave, okay? And in here I have the same diagram or another diagram, but just picking another example for wavelength, so you can see that you can pick other places for wavelength. Peak and trough are still showing an amplitude. In here it even looks like it goes a little bit more up than this, but there you go. Amplitude, the maximum displacement from the normal position. Now, if you remember my last video, I said for you to listen carefully what the surfer was saying about the size of the wave and the energy that he felt going into him and all that stuff. So if you have a wave with a bigger amplitude, then they carry more energy. And you can see that example actually when there are tsunamis, for example, you can see that the wave just carries everything in front of them. They just break everything, right? So these waves are very tall, therefore they carry lots of energy. The same if you talk louder, your voice is going to be heard further away from the source, so from you, so it carries more energy. So now now we know where to label the wave in terms of amplitude, wavelength and all these things. Let's see if we can use the same keywords in terms of describing what is going on, so if it's not a diagram. So pause the video if you don't want the answers just yet. I have the two columns for you to match them correctly. I have amplitude, frequency, wavelength, crest or peak. It can be called crest as well, and trough. And then I have 5 definitions, so I want you to join them together. So I'm going to start now, so pause the video if you want to do it. So wavelength, that's going to be the first one, the length of the wave. It is the distance between a point on one wave and the same point on the next wave. Wavelength is measured in meters, so that's the units. Now, crest or peak, they are at the top of a wave, is the highest point of the wave. On the other hand, the bottom of the wave, the lowest point of the wave, is the trough. Then maximum distance from the normal position, which is measured in meters as well, that's going to be the amplitude of the wave. Which means that frequency, which you cannot show in a diagram, is the number of waves that pass a certain point in the medium every second. The units are hertz, Hz, or second minus 1. So frequency, number of waves passing through you every second, okay? Alright, now if I have the frequency and the wavelength for a wave, I can figure out the wave speed. So this is known as the wave equation, okay? And I have here the equation with the actual words, and I have here the equation in symbols. So wave speed, which shows as a v, equals frequency that has this Greek letter, the mu, times wavelength, which is the lambda, okay? So wave speed in meters per second is equal to the frequency, which is hertz, the same thing as 1 over second, times wavelength in meters. So of course, if you multiply meters by 1 over second, you get meters per second. Okay, so for example, let's try this exercise. A source generates 5 waves per second. Each wave is 2 meters long. What is the wave speed? So frequency is 5, wavelength is 2. The formula says that I need to multiply frequency by wavelength. So I do 5 times 2 and I get 10. And to get full marks, I need to write the units, meters per second. Okay? More exercises. A stone is dropped into a pond. The waves travel outwards at a speed of 500 millimeters per second. The wavelength of these waves is 100 millimeters. What is the frequency? So wave speed says that is frequency times wavelength, so I can rearrange the formula to get frequency. That's going to be the speed over the wavelength, so I do 500 millimeters per second divided by 100 millimeters. So this is going to give me the number 5, and then the units are going to be 1/second, so hertz. Okay, there we go. 10 complete waves pass a certain point in a medium in 1 second. The wave speed is calculated to be as 20 meters per second. What is the wavelength? So again, I need to rearrange the formula that says that wave speed equals frequency times wavelength. If I want wavelength, I do the speed over the frequency. So I do 20/10. So this will be 20 meters per second divided by 10 hertz, or 10 1/second. So the seconds 1/seconds cancel out. So I get an answer of 2 meters. Finally, last exercise of the extension. If you increase the frequency of waves through a medium, what will happen to their wavelength? Explain. This is obviously assuming that the speed is the same. Now, because frequency and wavelength are multiplying each other, because the wave speed is the same, since the waves are moving in the same medium, so the frequency increases, therefore the wavelength decreases, okay? So higher frequency means shorter waves or shorter wavelength. Low frequency means waves with a longer wavelength, okay? More things you need to know. Sometimes people confuse wave speed with frequency, because wave speed is how many the speed that the wave is passing through me, while frequency is how many waves I have through me, okay? So frequency and wave speed are completely different things. The frequency depends on the source, how many times it vibrates every second, while the wave speed depends on the medium that the wave is traveling through, so how fast the wave can go, okay? So I'm almost at the end. Just to let you know, there is here a video which talks about waves, so a little bit of a recap. And he has a guy on the video in this some space station, and he's showing some waves at 0 gravity, so you can actually see without air resistance the waves going back and forth. Okay, so it's an interesting video, not necessary for you to understand what is going on in here, but it's an interesting video. Now, quick quiz. Which wave below is a longitudinal wave? So, ultraviolet, water, light, and sound. Ultraviolet and light are electromagnetic waves, so they need to be transverse. Water waves are transverse as well, so the answer will be sound, okay? Next question. What are the units for frequency? Frequency is hertz, which is 1/second, so D is again the answer, hertz. Next question. A wave has a wavelength of 6 meters and a frequency of 5 hertz. What is the speed of the wave? Wave speed is frequency times wavelength, so 5 times 6, that gives me 30, and the units will be meters per second, so again D is the right answer, 30 meters per second. Final exercise. What is the speed of this surfer? Now, there are 2 ways of doing this exercise. Speed equals distance over time. He travels a distance of 12 meters in 1 second, so it's 12 divided by 1, that gives me 12 meters per second. But in terms of waves, you can also do this exercise. Let's just think about it. There are 3 complete waves showing, okay? 1, 2, 3. So in 1 second, so the frequency is 3 hertz. Because, and I know it is 1 second because this shows 1 second later. And then there are 12 meters for 3 complete waves, so that means that the wavelength is going to be 12/3, which is 4 meters. So I got the frequency, I got the wavelength. Wave speed is frequency times wavelength, so 3 times 4, that gives me 12 meters per second. So there you go, another way of doing these exercises, because sometimes it may be that you are not given enough information and you need to calculate this stuff just by looking at the picture. So there you go, wavelength, amplitude, speed, frequency, all of that, all properties of waves in terms of describing them. Up to my next video, be happy and healthy. Bye!